first one we're going to see about inheritance. Actually, it is a process where the child class inherits the properties of the parent class. Here is the syntax for that, and this mechanism can be done by using the extends keyword. Here, first of all, the class is the keyword, and the next one, the child class name for the extends keyword, and then the parent class name. Inside the curly braces, you can give the child class methods as well as the variables. Here is a simple program for the inheritance. Here we have two classes, that is the employee and the manager. Here when it comes to the relationship between the two classes, we have a set of employees, and here the manager is going to be the one of the employee, right? So we are taking it as a child class, and the employee has been taken as the parent class. In case of this parent class, that is a single variable, that is the salary, which has been initialized to 5,000. In case of this manager class, we have a single variable that is initialized to 3,000. And we are going to extend this employee by using the extends keyword, and this manager class acts as both the main class too. So inside the main class, I am going to declare a variable m, which is the name of the object of the class manager. And through this object, we are going to access both the variables salary as well as the bonus by using the dot operator. That is, we have given it as m dot salary. So this m is the name of the object of the class manager, and this is the salary is going to be the variable of the class employee. And the next one is this m dot bonus. Here this m denotes the same the object name, and here this bonus denotes the variable that has been declared inside the manager class. So this comes the types of inheritance. Here there are 5 types of inheritance. First one is the single inheritance, second one is the multi-level, third one hierarchical, fourth one is the multiple, and fifth one is the hybrid. In case of the single inheritance, that will be single parent and that will be single child. Here this arrow mark denotes the parent class. So this class A is the parent class and class B is the child class. In case of this multi-level, that can be any number of child class and that can be any number of parent class. For example, here this class A is the parent class for the class B, and class B is the parent class for class C. So here the class B accesses both the parent class as well as the child class. So in algebra we see that there are 2 parent classes as well as 2 child class. So in the similar manner, you can have any number of parent class as well as any number of child class, which are differentiated by the levels. And the third one is the hierarchical one. In case of hierarchical, there will be a single parent class. Here it is class A, and there can be any number of child class. Here the class B and class C are the child classes. In case of the multiple inheritance, there can be any number of parent class, but there should be a single child class. So class A and class B are the parent class, and class C is going to be the child. And in case of this hybrid, it is a combination of any 2 types of inheritance. Here I have given the combination of hierarchical as well as the multiple inheritance. Actually, the upper part denotes the hierarchical inheritance. That is, class A is the parent class, class B and C are the child class. And here the lower half, that is class B, C and D, that denotes the multiple inheritance. Right, so class B and C are the parent class for the class B. This is the example for single inheritance. Here we have the class that is the student, that is going to be the parent class, which has the function that is mark, that is function definition for mark. And then there is another class called counseling, which extends the class student. So counseling is going to be the child class and student is going to be the parent class. And this child class has a single method definition, that is the cutoff. In case of this main class, we have test inheritance, which acts as a main class, and inside that we are going to declare a variable b, which is the object of the child class, that is counseling. Through this object, we are going to call the functions of both the student as well as the counseling class by using b dot mark as well as g dot cutoff. And next comes the multi-level inheritance. Here, as we said already, there can be any number of parent class as well as there can be any number of child class. Here first one we have the class student that acts as the parent class, and the second class is counseling, which inherits the concept of this student. So counseling is a child class of the class student, and then next one we have the another class called the scholarship that also acts as the child class and whose parent class is said to be the counseling. Right. So all these classes have a function that has been defined itself. That is, mark is the function of student, cutoff is going to be the function of counseling, and further the fund is the function of scholarship. In case of this main class, we are going to initialize a variable that is D, that is the object of the class scholarship. Through this object, we are going to call all these three functions, that is mark, cutoff, as well as the fund, as the scholarship class will inherit all the properties of counseling as well as the student. Next one is hierarchical inheritance. In case of hierarchical inheritance, we have the class student. Again, the function is going to be the mark, and in the second class is going to be the counseling, which inherits the properties of student. And we have the third class, that is sports. Sports, which extends the class student. So here there are two child classes, that is counseling as well as the sports, and a single parent class, that is the student. Now, in order to access these functions, we need to declare the objects for two classes, that is counseling as well as the sports. So we have C is the object of the class counseling, and S is going to be the object of the class sports. Through those objects, we are going to call the functions cutoff as well as the mark, that is C dot cutoff and C dot mark. And through the sports class, we are going to call S dot mark as well as S dot events. Next comes the polymorphism concept. So what is polymorphism is that a single object will take many forms. For example, if we take our smartphone, our goal is to have the communication. That is our main goal. But it can be done in a number of ways. That is, can be done through a call, or it can be done through a text message, or it can be done through a picture message, or it can be made of anything. But our goal has to be attained, but it can take any form of the communication. That is the main concept of polymorphism, right? And in case of polymorphism, there are two types. First one is the compile type polymorphism, and second one is the runtime polymorphism. In compile type polymorphism, again we have two types, that is the constructor overloading as well as the method overloading. And what's in the runtime polymorphism is that it is the method overriding concept. That is the runtime polymorphism. When we come to method overloading, a single method will have the different forms. Right here we have a single method, that is the display. This display method can have three forms. That is, in first form, that is a single argument, that is of character type. In second form, it has the single argument of type integer, and in third one, it has two arguments of type integer as well as the double. So it can have different forms, but the number of arguments or the type of the arguments or the order of the arguments has to be varied. It can be in such a manner. Here the goal is that whatever the argument that has been sent to the function display, it has to be displayed. Okay, whatever arguments that has been sent, it has to be printed. So that is the goal. So but it can have the different forms of character type or integer, or it can be of int as well as double. Here, this comes the ways to overload. Actually, there are three ways for overloading a particular method. That is, as I said already, it can be by varying the number of parameters that we are going to send. How it can be the data type of the parameters that we are going to send, or it can be of the order of the parameters too. But in case of Java, we cannot have the overloading concept by changing the return type of the method, right? Here this is the example for method overloading by varying the number of parameters. Here we have the class display overloading. It has two functions. That is, the function name is just display, but it has two forms. In the first form, the argument is of type character. In the second form, the argument is of type character as well as the int. Right? So in the main class, here the main class is going to be sample. In this main class, we are going to create an object for the class display overloading. So here the object name is obj. Through that object, I am going to call the display function with the argument a. Since a is the character, the first form will be called and it will be printed. Here, when I call the second form, that is display of a, 10, arguments is going to be 2. So it will call the second form of display. So character C, comma, if num will be called and then both will be displayed. Next comes the second type, that is by varying the data type of the parameters. Here we have the same class, that is display overloading of true, and we have two forms. In the first form we have the character as the argument, and in second form we have the integer as the argument. So in case of this main class, in the first, that is obj.display of a, I am going to send a particular character, that is I am going to send a. So the first form of display will be called. In the second line, I am going to send the 5 as an argument. So second form of the display will be called since it is an integer. Next one is this the method overloading by varying the order of the parameters. So in this class we have two form methods. In the first form, the first argument is character and the second argument is the integer. In the second form, the first argument is the is of integer and the second one is the character. So based on the order, right? In the first calling, we are sending x comma 51. So first one is the character and the second one is the integer. So first form of the display will be called. And in second line we are sending 52 comma y. So which one is of the second form? So second form of display will be called. Next comes the constructor overloading. So before going to the constructor overloading, first we will see about the constructors. So what is meant by constructor is that it is also a block of code. It is just like method, but it does not have any return type, and the name of the constructor will be same as that of the class. We cannot have the different name. And these are the key differences between the constructor and method. In case of constructor, as I said already, there will be no return type. In case of method, there should be a return type. In case of constructor, we need not call the constructor explicitly. It will be called automatically whenever the object is created. But in case of this method, we have to call it explicitly through the objects. And the third difference is that it must have the same name as that of the class. But in case of method, it must have the different name. And in case of constructor, it cannot be static. But in case of method, it can be a static method too. Here this is the example of the constructor. Here we have the class student. Here the constructor block has been given in red. That is student of int I comma string n. Then that particular block is called as the constructor. Here the class name as well as the constructor name is same, that is student. So in case of main, when we go to the main function, I am creating an object that is s1 and s2 of the type student. So whenever these objects are created, the constructor student will be called automatically. So when the line student s1 is equal to new student of, when that line is executed, the constructor will be called and the values, the triple one and current will be automatically copied to the variables I and n. Okay. When it comes to the student s2, the value is 222 and value will be copied to I and n when the constructor student has been called. And next comes, so this is the example for constructor overloading. Here we have the same class that is student, but we have two constructors. That is, in the first constructor there are only two arguments, that is int I and string n. But in case of second form of constructor, we have three arguments, that is int I, string n, and as well as the int a. So when I am creating the object of the class student, that is student s1 is equal to new student of triple one comma current, I am passing just the two arguments. So since it is the two arguments, the first form of the constructor will be called. When I come to the second object, that is s2, I am going to pass three arguments, that is 222, rn and 25. So the second form of the constructor will be called. So this is the example for constructor overloading, that is based on the data type or based on the number of parameters or based on the order of the parameters, the constructor has been called when the object has been